This is G484 homework booklet question number 15. Part A of this question is quite nice and straightforward. It's careful use of some equations. So first of all, gather the information. We're given the radius of the London Eye, and we're given the speed at which each capsule is moving around in the circle. And we want to find the time for the wheel to make one complete rotation. So we have here the equation for speed, really based on distance divided by time, because we have the distance to go round the circle once equals the circumference, and the time to rotate once is the period. So substitute in the values given, rearrange carefully for t, and solve to find the answer in seconds. The next part is just asking us for the centripetal force on each capsule. So our standard equation for centripetal force, mv squared divided by r, and a very straightforward substitution to get the answer of 10.9 newtons. The next part of the question takes a little bit more thought and understanding of the physics involved. We have a spin dryer with a sock rotating round on the inside here. And first of all, we just have to mark the direction of the centripetal force at each of the 3 points. So that should be straightforward, just marking each one pointing towards the centre. Do be careful with your drawing that your arrows are accurately pointing towards the centre, so at least by eye it would be judged that way. Moving on, here's the challenge. State and explain at which position the normal contact force between the sock and the drum will be greatest and least. This really does need you to understand the physics of the forces involved. This first mark here for the answer C is a method mark, so if you get the answer wrong here, you'll get nothing for your explanation. But you need to think carefully about the forces involved. So why is it greatest at C? The centripetal force is provided by the net force of the normal reaction and the weight. The normal reaction is pointing upwards here, and the weight would be acting downwards. So the centripetal force could be given by this equation. You have, however, been asked about the normal contact force, which is R. So if you rearrange this equation, you would have that the normal contact force R equals the centripetal force plus the weight. Put into words, that gives this answer. The force must balance the weight and provide the centripetal acceleration force. Having recognised that at the point at which the normal contact force will be the greatest, it probably makes sense that it will be least at A. Think again about the forces involved. The centripetal force is again a net force. It occurs with the normal reaction acting downwards and the weight acting downwards. This means that the normal reaction is going to equal the centripetal force, take away the weight, so it's less. So, in words, the weight is providing part of the required centripetal force, so the normal reaction will be less.